So while we were deciding what topic we were going to be discussing in our project, we realized that we were both pursuing a career in computer science, and since this is something that we should both be knowledgeable in, we decided that this was a perfect way to combine both this class and our aspirations into one. And this will serve as a good way to get a head start on subjects that we're going to be learning about in the near future in later classes, and it'll help us have a deeper understanding when we do come across these topics because we'll have some prior knowledge on what it is that we're learning. And since computers are used by almost everybody, and everybody in this class, since we're taking this online, definitely has a computer, we felt it was important that everybody should be informed on what it is that they're using and understanding how it is that they work.
Okay, I'm going to explain what is a CPU and what is so important to recall among all the components of the computer. What is so important to recall the CPU? The CPU is also known as a processor. It's the logic circuitry that drives a response and processes the information given to the computer. Let's say in other words, not in logistically way, the CPU is when, for example, you press the letter A in your computer in the keyboard, then the CPU gets the signal from your keyboard and then send the output to your computer, so the computer output is at the letter A. So that's why it prints the letter A when you press the letter A. Now, the CPU now in nowadays it's becoming more smaller, tiny every day. Since it's a nanotechnology, and when the technology of today is being measured at least less than 9 nanometers, and in other days will be less.
So the main component or material found in a CPU is called silicon. And silicon is a metalloid, which means that it shares both characteristics of a metal and a nonmetal. It is very cheap and found almost anywhere in the world and is one of the most abundant resources in the world. And what makes it so special is that it conducts electricity and it can handle a very high range of temperature, which is extremely important in a computer because your computer can get hot really fast and it reaches sometimes even upwards of 80 degrees Celsius, and so it needs to be able to handle high temperatures so that it doesn't melt and the computer can continue working like normal. And it is what's called a p-type semiconductor, which allows the current to flow along the material, but it only travels in one direction. The silicon is used into what's called a transistor, which is present in the CPU. And the silicon that is used for that transistor comes from sand. Sand is made up of silicon dioxide, and then through various chemical and physical processes, the silicon is extracted and it's formed into a very large rod in a crystalline form, similar to the pictures shown before. And from that rod, various sheets of crystal of silicon are taken out, which are then modified to be both negatively charged and positively charged. The blue portion that you see on the picture on the left are the negatively charged silicon crystals. The orange portion below that's labeled P is the positively charged silicon crystal. Then on top of that you have an orange coat of what's called silicon oxide, and that serves as an insulator. And then the red portion is what's called polysilicon, and it is highly conductive. So the blue portion, which is the negatively charged silicon, receives two charges, one on the left side, one on the right side. The left side will be positively charged, the right side will be negatively charged. And the middle polysilicon receives also a positive charge, which creates a bridge between the two, blue or the negatively charged silicon, and that allows for the current to flow through in one direction and creates a closed circuit, and that way electricity can flow from one side to the other.
The reactions taking place at the CPU are when they are producing, like the chips, the little chips when they are producing. There are many reactions can happen there, like for example synthesis reaction, singular replacement reaction, and both ionic and covalent bondings. That happen because it becomes from a little sand to become a chip. So the layers between among them change a lot and the silicon expand in many sizes. And another reaction that is after the production is the use during the use of the CPU. That it hits every time because each time it receives instruction from the computer, it reads and sends back an output or an input to the computer. In other words, it sends back an answer to the computer. However, it does occur in less than 1 nanosecond, and the velocity is what it makes it to be hit like that. I just wish you liked this presentation. I just want to say in conclusion that both of us, this project has helped us to get a better understanding of the components of a CPU and how the materials used can have a big impact on the functionality of the component. For example, the CPU in the computers, the mobiles, all those technologies of every day. Through this, we can have learned that we can try new things, new components, new materials we can try on to find a material that will be capable of handling even higher temperatures than the silicon that currently we're using every day. And maybe one day we'll make a breakout on the speed at which computer works.